So in this session, we will do multiple choice questions related to organic chemistry from Unit 4. So these are from different past papers, like this is from January 2010 paper. So which of the following molecule is a methyl ester? Methyl ester means which contain a methyl group. And both sides should be methyl. Like example, when we name ester, the first side is coming from alcohol and the second one is from carboxylic acid. So it should, to be a methyl ester means what should be the name? It should be methyl methanoate. So to be a methyl methanoate, when we check the first option, the two carbon atoms are there. So two carbon atom, which is ethyl ethanoate. But when we check the second one, it is one carbon methyl, and because of this functional group, it will be O8, and there's one carbon, so it will be methanoate. That's why B is the right answer. D is not an ester, and C is also it's not an ester. It's actually about ketone. In question 8, during the preparation of a liquid compound, a sample were taken of the product and various stages in the purification of procedure. Which of the following technique would be most suitable for showing the change in composition of a sample during the purification? Like how we can identify the sample has changed or it contained different components during the composition, like when we are carrying out. So filtration is there, as you can see, during the preparation of a liquid compound. Samples were taken of the product. So we take out sample from the product at different stages in the purification procedure. And which of the following technique would be the most suitable for showing the change in the composition? So using a column chromatography or liquid or gas liquid chromatography, we can identify the composition as well, the proportion as well, proportion of each sample. In fraction distillation, it can be used, but it cannot be used to identify the proportion. We can separate the two miscible substances from each other, but it does not determine the proportion. Filtration, why it is not valid here? Because liquid sample is there, so filtration is to separate the solid from, and simple distillation is there to separate the liquid from the solution, to separate the liquid from the mixture. But here, because a liquid compound is there, so that's why it must be, why fraction distillation is not there? Because fraction distillation can separate them, but it cannot be identify the proportion, the composition. That's why the column chromatography or gas liquid chromatography is the most suitable technique. Then another question: which of the following compound would react with lithium tetrahydro dualuminate and also with phosphorus PCl5 or phosphorus pentachloride? Basically, lithium tetrahydro dualuminate is a reducing agent. So it can reduce the substance, and PCl5 is a test for the presence of OH. If anything is having a OH, as a result, it will give a positive result with PCl5. So it can be alcohol, it can be carboxylic acid. So when we check the second option, PCl5, it can react with alcohol or carboxylic. So either A can be an answer or D can be an answer. Then when we check the reducing agent, as we know, if we have if we have primary alcohol oxidized to aldehyde and aldehyde oxidized to carboxylic acid. So if you have carboxylic acid, it will, using a lithium tetrahydrodualuminate, it will be reduced to primary alcohol. But as you can see here, so this is a carboxylic acid can be reduced. But when you can see here, This is alcohol and it's a primary alcohol, but primary alcohol cannot be reduced. It can be oxidized to aldehyde or to carboxylic acid. So the reducing agent is valid only for reduction of carboxylic acid or even for reduction of ketone. So if it is a carboxylic acid, it will reduce to primary alcohol. If it's a ketone, then it will reduce to secondary alcohol. So that's why A is the right answer. Is it clear, discussion? In this question, in the synthesis of ester, the use of acyl chloride and alcohol give a better yield than use of carboxylic acid. What is the reason for that? Because when we are using a carboxylic acid, the reaction is reversible. But in case of acyl chloride, the reaction is irreversible, so reaction will goes on completion. So acyl chloride and alcohol is in equilibrium. No, that's not about their goes on completion. Acid and alcohol does not goes on completion. That will be in equilibrium. Acid and alcohol requires a catalyst. It required, like, sulfuric acid is used as a catalyst, but it's not about like why we have a better yield. That's not the reason for that. There is a catalyst, sulfuric acid is there as a catalyst for formation of ester, but not related to the explanation as I mentioned why we have a better yield with acyl chloride and alcohol, because the reaction goes to completion. Not all molecules will absorb infrared radiation, those that do. So all molecules are not able to absorb infrared radiation, but those molecules which absorb, what should be the condition? Because when the molecule absorb, they tend to bend, stretch. Like example, if you have C double bonded with O, or you have CH, so what happens when IR radiation or infrared radiation being absorbed? So the bond will stretch, or the molecule might rotate or bend. So the bond length changes when we expose these molecule, their bonds to IR radiation. So change their dipole moment. What is the meaning of a dipole moment? Dipole moment, basically a net charge appear on the element due to loss or gain of electron, or due to difference in the electronegativity. So this will be partial positive, oxygen will be partial negative, and the dipole moment depend on the charge on them. But as a result, as the bond length changes, the polarity, the magnitude of this partial positive and negative also changes. So magnitude of partial positive and negative also changes. As a result, what happens? The molecule will absorb infrared radiation. Is it clear? Then another question: which of the following method may be used in a single step to make a carboxylic acid? Like directly we can make a carboxylic acid. Which technique or which method can be used? So if we do hydrolysis of the ester in the presence of an alkali, that alkali, which of the following method could be used in a single step to make carboxylic acid? So we want to make carboxylic acid in one step. So when we check the options, hydrolysis of the ester, when we do hydrolysis of the ester, the product will be, so the product will be alcohol and acid. But that acid which is formed here directly react with an alkali, to form a salt. So we cannot use, A cannot be used. When acidified potassium manganate is reacted with alkene, so it will produce diol. The product will be diol. So it won't be accurate. So second technique will produce diol. The third one, hydrolysis of the nitrile group. These nitrile groups, when we do hydrolysis, so as a result, what will produce? It will produce carboxylic acid and ammonium salt. So as a result, because the carboxylic acid is there, so in a single step, we are able to produce these carboxylic acid. Then the reaction of acyl chloride with ammonia. If we have acyl chloride, like example, if ethonyl chloride is there, reacted with ammonia, which is NH3, so it will be NH2NH. This will be partial negative, positive, partial negative, positive. So this Cl will take position of NH2. As a result, it will produce CH3, C double bonded with O. NH2 will be there, so amide will be produced, plus HCl misty fumes will be there. So it does not produce carboxylic acid. That's why C cannot be, D cannot be. So the correct option is C. Is it clear? This one. Then another question. Which of the following reagent could be used to produce propanamide? So we want to produce propanamide. This is a product. This is propanamide. So what we should use, because if propenyl chloride is there, if we have propenyl chloride means CH3, CH2, C double bonded with O and Cl. That's propenyl chloride. And it reacted with ammonia. Ammonia is NH3, but I'm writing in terms of polarity. So this will be partial negative, positive, partial negative, positive. So chlorine will displace. So as a result, what will happen? So CH3, CH2, C double bonded with O and NH2 plus HCl. So this is a propanamide which is produced by reaction of ammonia with. If you have halogen alkane, like example chloropropane is there reacting with ammonia, so it will not produce amide. This is amide, this will produce amine. Same thing, methylamine react with one chloropropane, so it will produce multiple substitution will occur, but it will not result in a formation of amide. Is it clear? Question 14. So when we complete the products, the example of ammonia is reacting with one chloropropane. One chloropropane means first carbon is having a chlorine. So this is CH2, this is CH2 and CH3. And the chlorine is attached. So this will be partial negative, this will be partial positive, and in ammonia NH3 is there, but NH2 is partial negative and H is partial positive. So this negative part will displace this chlorine. So what will be the product? The product will be CH2, NH2, then CH2, then CH3 is there, plus HCl. So what you can see, this is not a amide. It is amide because amide means the functional group should be C double bonded with O and NH2. That's amide. But if you have C and NH2, that means it is amine. So this will produce an amine. It does not produce amide. We want to produce amide. So that's why A cannot be an answer. B is the right answer, we already discussed. But why C cannot be a right answer? If we have methylamine, so methylamine means CH3, NH2. This is partial positive, this is partial negative. And in terms of when we write like CH3, NH2 is there. So in CH2, NH, this whole partial negative, and hydrogen is partial positive, because comparatively there is a greater difference in the electronegativity between nitrogen and hydrogen as compared to nitrogen and carbon. So partial negative, positive. This is methylamine. React with one chloropropane. So one chloropropane means like CH2, CH2, CH3, and then Cl is there. Partial negative and partial positive. So what will happen? This hydrogen will be replaced by this whole carbon chain. So it will produce CH3, NH, and then CH2, CH2, CH3 plus HCl. So what is the name of this product? It is N-methyl, N1234. So N-methyl means, like, because methyl group is attached to nitrogen, so that's why we call N-methyl, and 1, 2, 3 are there. So it will be prop N amine. So it is N-methyl propanamine is there, but not the desired product which we want. And when we check the last option, methylamine react with propenyl chloride. So methylamine is CH3, CH2, CH3, NH2 is there. But because in NH is partial negative and hydrogen is partial positive. And propenyl chloride, prop means 3 carbon, and acyl chloride, so C double bonded with O and Cl. When we compare, so again, the partial, this is partial positive, this is whole is partial positive, so this carbon chain will take position of the hydrogen, and as a result it will produce amide. So this will be CH3, NH, then C double bonded with O, CH2, CH3. So what is the product here? This is N-methyl, because with nitrogen methyl group is there. So this is N-methyl 1, 2, 3. So prop, because they have single bond N, and due to this functional group C double bonded with O and N, this is amide. So it is N-methyl propanamide. So the product, when we check for B, it is a valid product. Then what is the purpose of the radio waves in proton NMR, nuclear magnetic resonance? What it do? Basically, hydrogen contain one proton and one electron. And there's a magnetic field of a proton and electron, but mainly it's because of the nucleus of hydrogen, proton magnetic field is there. So when we use these radio waves, what the hydrogen will absorb these radio waves and they will flip according to the change, because the movement or the spin of the particle, because spin is also a movement, is a reason for the magnetic field, or motion of the particle is reason for a magnetic field. So what happened? Example, if this proton is moving anti-clockwise, say dipole produced in this manner, but when we pass these radio waves, basically what it do, it change the spin of the particle. As a result, when it change the spin of the particle, the same particle which was, for example, moving anti-clockwise, but now start to move clockwise. As a result of a clockwise rotation, the dipole will also change, or dipole will be in opposite direction. So the radio waves used in proton NMR, what is the purpose of these radio waves? Must not be absorbed by the sample, that is wrong. Cause the electron to transit, that's not for causing an like excitation. Can only be used with organic substance. No, it can be high substance which are having, like, normally if any atom is there which is having a net dipole net magnetic field, so we can use this. Cause the hydrogen nucleus to change its spin, that is correct. Like first if it was clockwise, then anti-clockwise, which result in a opposite magnetic field, and it will flip between the two states. And like first example, this was a magnetic field applied. When we pass the radio wave, it absorbs and it adjusts according opposite to the direction of the applied magnetic field. And once it returned back, it released that energy, so we can identify the number of proton or hydrogen environments, as well as we can also identify the total number of hydrogen in each environment. The area under the graph shows the total number of hydrogen in each environment. In question 18, This is about the polymerization when you have diol react with dicarboxylic acid. So if one side, because all of the polymers are starting with O, so it means if one side I remove H, the other side I should remove OH. So one side H, the other side I should remove OH. So if we consider like this, when we check option A and B, option A and B are not correct. Why they are not correct? Because they did not repeat. Like example, you can see this part is coming from alcohol, then for acid, and then for alcohol. So then there should be another part coming from acid. That's why A and B are totally wrong. Now we are left with C and D, because if we are making a repeat units, so we should also repeat the same cycle. Like if one molecule from alcohol, other from carboxylic acid, then another alcohol and carboxylic acid. It cannot be like three in the unit. There should be another one. So that's why A and B are totally wrong. We are left with C and D. So if I try to draw a polymer or construct a polymer, so I remove, why I remove H from here? Because all the options are starting with O. That's why if I remove H, then it will be CH2, CH2, OH and H being removed. So if OH and H being removed, so basically this one of them is C double bonded with O. So one will be O, another one is C double bonded with O. Then there's a box, and then C double bonded with O. And because we remove OH, so there should be bracket and N. So it matches with option C. So C is the right answer for this one. Is it clear how we construct a polymer? Then in question 7, hydrogen cyanide HCN react with propanol. As you can see, an aldehyde is there in the presence of potassium cyanide KCN. What is the mechanism of this reaction? How this reaction proceed, or how this reaction occur? So when we check how this reaction proceed, so aldehyde is there, which is C double bonded with O and H, and then alkyl groups are there, CH2 and CH3. So this KCN will dissociate into K plus and Cn minus, and this Cn minus, because oxygen is partial negative and carbon is partial positive, so this is having an extra electron, a lone pair, uh, a pair of electron is there that can attack on this partial positive, and when it will attack on this partial positive, this will be removed, like because this hydrogen will be there to. So as a result, what happened? This oxygen will break the bond, oxygen will take the electron, and oxygen will get a negative charge. So this will be CH2, CH3, H is there, and then Cn is there. The whole molecule get a negative because oxygen took these two electrons which are involved in the bonding. And then as a result, what happened? HCN is there. So this is partial negative, partial positive. So this is attracted towards the hydrogen, the partial positive side is there, attracted towards oxygen, and it will try to form a bond. So it will form OH is there, then CH2, CH3, then Cn is there, and H is there. So it convert into a nitrile group, hydroxy and nitrile group. So what is the mechanism of this reaction when we compare? Because basically what happened, all the reagents which are, First thing, either it is electrophilic or nucleophilic. How the reaction started? By attacking on the positive center. So when attack on the positive center, it means it is nucleophilic. So it cannot be C or D. Then we have to identify whether it is addition or substitution. You can see all the reagents are added, nothing being removed or displaced. So it means it is nucleophilic addition reaction. Is it clear? Discussion. Then the next part, the first stage of the mechanism is like how the reaction started. What is the first stage of the mechanism? The lone pair of electrons on CN group, because the lone pair of electron on CN group attacking on the partial positive propanol aldehyde, that's true. This is what is happening. So that's why A is the right answer, because the reaction started when this lone pair attack on the carbon partial positive. Then the product of the reaction. So what is the product of the reaction? As we already completed, this is the product of the reaction, the last thing. So when we name this is a carbon chain for us. So we have 1, 2, 3, 4. So 1, 2, 3, 4. So second position we have hydroxy group. So it is 2 hydroxy. And there are 1, 2, 3, 4 groups. So it will be but. So 2 hydroxy is there. Means second position we have OH group as a branch. So that's why we call that as a hydroxy. And because there are 4 carbon atoms, so that's why it is but. They have a single bond ane. So, but we will write ANE full. We will write ANE. What is the reason for that? Because the overall group is having, like the functional group is not starting with a vowel. That's why it's butane. And then at the last, we write as nitrile. So it is 2 hydroxy butane nitrile. That's a name of the product form in this reaction. Is it clear? This one? Then which of the following does not have hydrogen bonding in a pure sample but form hydrogen bond when it dissolve in water? Like inside it does not have its own hydrogen bonding, but when it dissolve in water, it can form a hydrogen bonding. Look, alcohol, all alcohols have hydrogen bonding. It get weaker as the carbon chain increase, but they have hydrogen bonding. All the carboxylic acid, because hydrogen bonding, when hydrogen is directly bonded with most electronegative element such as oxygen, fluorine or nitrogen. In propane, there is no hydrogen bonding. Why? Because the carbon is directly attached to hydrogen and there is no lone pair. Here what happened in propanol, within propanol, because this is a structure of propanol, CH3, CH2C double bonded with ONH. That's a structure of propanol. So inside, because for hydrogen bonding, hydrogen must attach to most electronegative element, or hydrogen must be attached with either oxygen, nitrogen or fluorine. But in this case, in propanol, hydrogen is not attached. So within the molecule, like when we have all the propanol molecule, there is no hydrogen bonding. But as a result, what happened when we dissolve in water, when we mix with water, so there are lone pairs on oxygen, and these lone pairs and there's a lone pair on this oxygen as well. So these lone pairs are attracted towards the hydrogen, which result in a formation of hydrogen bonding. So within the molecule, why they are not able to form hydrogen bond? Because the hydrogen is not attached with the most electronegative element. But when they are mixed with water, because the water contain hydrogen attached with oxygen, so the molecule also start to form the hydrogen bonding. That's why B is the right answer. Then which of the following exhibit both optical and geometrical isomerism? Ez means geometrical. Look, to be an optical, the carbon, what is the condition? The carbon should be attached with four different groups or four different atoms or different types of atoms. And to exhibit Ez isomer, there should be a carbon-carbon double bond and there should be different groups attached. Like if there is CH2 is there with a carbon, they cannot have a geometrical isomer. So when we check option A, it cannot have a geometrical isomer. Option B cannot have a geometrical isomer. So we are left with option C and D. Now in C and D, we have to check which one having the carbon atoms bonded with a different electronegative, like bonded with different types of atoms. All the groups should be different. So when we check option C, this this carbon having two hydrogens, so this cannot be a chiral carbon. This carbon, because there should be four different groups. But the problem here, this carbon is having a double bond with another carbon. So double bond cannot be a chiral carbon as it is already having two bonds here. Because to be a chiral carbon or to show an optical isomer, it should be attached with the four different groups like W, X, Y, and Z. So this cannot be, this carbon cannot be. When we check this carbon, whether it is a chiral carbon or no, we were checking option C. So when we check this carbon cannot be. When we check this one, this is CH2. Again, this carbon is attached to CH2, so two hydrogen will be there. Then chlorine and other side is CH. So this cannot be a chiral carbon because two same groups are attached. When we check option D, this cannot be chiral carbon. This can be, but this can be a chiral carbon because it is attached with four different groups around it: hydrogen, chlorine, methyl, and another CH group. So that's why this will exhibit both optical and geometrical isomerism. Is it clear? That's why D is the right answer. So if you want to check the optical isomer, you should check four different groups must be attached. If you want to check the geometrical isomer, then there should be no identical, there should be a carbon-carbon double bond and different groups should be attached to the carbon atoms. How D will have geometrical? When you draw the structure, there are two ways you can draw the structure. This is a carbon attached with a carbon. So one hydrogen is there, chlorine, and this is hydrogen is attached, and then CH is there. Then Cl is attached to this, and then CH3. So to be a geometrical isomer, when we check the two different group, like in terms of mass, so this is a heavy group. Here, this is a heavy group. So two identical groups, heavy groups are on the same side. So we can say cis or Z. Normally, when identical heavy groups are there, we use the term cis, but now we can say Z. And if they are on, we can draw other way around. So when you check the heavy group, now it becomes trans or E. So this is a heavy group, and this is a heavy group in terms of mass. So this will be E. So one is Z, another one is E isomer. So in this question, one optically active isomer of 2-chlorobutane react with hydroxide ion to form butanol. The organic product is a mixture of enantiomer. Enantiomer means like it contain both optical isomers. So when we have a mixture of our optical isomer, Well, like one can rotate the light clockwise, another anti-clockwise, so we call them as enantiomers. So what is the reason for that? Enantiomers are always formed when we have a chiral carbon, and basically the carbon, how this reaction proceed, what is the mechanism of this reaction? Basically, this is a tertiary halogen alkane. If you remember AS mechanism, C2H5 is there, then this is Cl and CH3 NH. So what happened? First, the bond breaking will occur in in this compound. First, the bond breaking, because the tertiary halogen alkane cannot react in one step, multiple step they react. So first the bond breaking, chlorine will take the electron pair. So as a result, it will form a carbon cation, carbon positive ion. And this carbon cation, C2H5 and CH3, so attacking nucleophile, the OH group can attack from the left hand side, like, or equal possibility it can attack from right hand side. So because both possibilities are there, the carbon cation which is formed in the intermediate, and as a result of this carbon cation which is formed in the intermediate, it can result in a formation of both products, like both products can form. So 2-chlorobutane, this is 2-chlorobutane, forms a carbon cation as an intermediate, and this carbon cation, due to the formation of carbon cation, the OH attacking nucleophile can attack from the left hand side or it can attack from the right hand side. That's why C is the right answer. Is it clear, this question 10? Because if the carbon cation is not formed, then only one side will be available to attack. But because the carbon cation is formed, so it is open from all the sides. That's why equal possibilities are there forming different enantiomers. The organic product for a reaction between ethonyl chloride and methylamine. So ethonyl chloride, how to draw ethonyl chloride? CH3, C double bonded with ONCl. This is ethonyl chloride. And methylamine, so CH3, NH2 is there, but NH is partial negative and H is partial positive. Here, partial positive, negative. So just remember, like, the partial negative side will take that position. So it will result in a formation of amide. So the organic product will be CH3, C double bonded with O, NH, and then CH3 is there, plus hydrogen plus chlorine. So misty fumes or hydrogen chloride will be there. So what is the organic product which is formed when these two are reacting with each other? So that is D. Only they are asking for organic product. They ask for total product, then it will be HCl as well. But the organic product will be N-methyl ethylamide or ethanamide, you can also say. The section of the polymer is shown. Which of the following monomers? So basically what happened, whenever a polymerization occur, you might have, like example, diol can react with dicarboxylic acid, or diol can react with ethonyl chloride, as they have a reaction between them. So when we try to complete a product here, so this will always remove this H and this will be Cl, and this will always remove its H and then it will be Cl. So what should be the polymer form? It will be O, CH2, CH2, then there will be O because the H is being removed, OH and H being removed, so O, C double bonded with O. And then CH2, CH2, and this C double bonded with O will be there. But you can see when the polymer which we drew, when in A they are reacting, that is oxygen is attached with the part which is coming from alcohol. But for there, the oxygen is attached with the part which is coming from either ethynyl chloride or any other. That's why it cannot be A. When we check B, alcohol and carboxylic acid, when alcohol is carboxylic acid, if one side you remove H, the other side it should be OH. One side H, other side should be OH. So it will be O, then CH2, then CH2, then OH is being removed, H is removed, so O, then C double bonded with O. Again, the same thing is there. It is not forming the desired polymer because OH on the left hand side, but in the polymer OH on the right hand side. So it means it is not forming the polymer which is shown here. When we check this alone cannot form a polymer because there is no, either should be OH group should be there attached to it. If this was alone, like alone means like this molecule, like all the identical are there. So this will be OH, CH2, CH2, C double bonded with O and OH. This is alone means like the same molecule. So if one side we remove H, if we remove H, the other side will be OH. One side H, the other side will be OH. So what will be the product? It will be O, then CH2, then CH2, then C double bonded with O, and this H is being removed. So this will be O, then CH2, CH2, and C double bonded with O. So you can see now it is forming a desired polymer. So that's why D is the right answer. Is it clear? The formation of the polymer. Then which of the following is not a reaction of Bronsted acid and base? Acids are proton donor, bases are proton acceptor. So when we apply this definition, basically this is not an acid base reaction, it's a substitution reaction, nucleophilic substitution reaction. So A is wrong, not the acid base reaction. A is a nucleophilic substitution. Ammonia plus HCl is acid base, water plus sulfuric acid, because there is a loss of proton and gain of proton. In this one, there is not a loss or gain of proton. The OH group displaces or replaces Cl. So it's a displacement reaction. Here there is a loss of proton and a gain of proton. Same thing here, loss and gain of proton. But in this case, there is no loss or gain of proton. It is about substitution. That's why A is the right answer. And for question 14, a buffer solution is made from ammonia plus ammonium chloride. When a small amount of acid is added to this buffer, a solution which resists the change in pH. So when we add acid, because a buffer solution contain weak acid and its salt, or weak base and its salt. So ammonia is a weak base and its salt is ammonium. So ammonium chloride will dissociate into ammonium ion, NH4 plus and Cl minus, and water is there, H2O. So it will produce NH4 plus and OH minus. Now a small amount of acid is added, or H plus ion is added. So what will be the result of adding H plus ion? So this H plus ion, because ammonia is taking proton from the water, so this H plus ion, when it is added, so ammonia will take this and it will also form ammonium ion. So the change, it resists the change in pH because it balances the, if we add one proton, because addition of the proton or change in proton or concentration of a proton leads to leads to change in pH. But if we add acid, that ammonia react with ammonium ion, hydrogen ion, as a result from ammonium, so it resists the change in pH. So these are some questions related to organic chemistry. Next session we'll do more questions related to the topic. Any question or a doubt related to the class today? we'll continue the MCQs tomorrow, and structure question next week.